This time, we will be talking on geometric series. When we say geometric series, it is the indicated sum of a geometric sequence. Example, in this illustration, suppose you send a chain text message to 3 friends at 7 a.m. And then, each of them passes the text message to 3 new people within the hour and so on. The number of recipients of the text message every hour forms a geometric sequence. If we are going to continue the pattern earlier in which the text message has been passed to 3 new people in every hour, the number of text recipients are reflected accordingly. For 7 a.m., there's 1 number of text recipient. At 8 a.m., there are 3 numbers of text recipients. For 9 a.m., there are 9 numbers of text recipients. For 10 a.m., there are 27 numbers of text recipients. For 11 a.m., there are 81 numbers of text recipients. For 12 p.m., there are 243 numbers of text recipients. For 1 p.m., there are 729 numbers of text recipients. So now, these numbers of text recipients are said to be geometric sequence because every 2 terms have common ratio, which is 3. So the question is, how many people will have received the message by 10 a.m. and by 1 p.m. To find the total number of text recipients at a given hour, we need to find the partial sum of the terms of the geometric sequence. This table will show us the series of the number of text recipients in every hour. For series of 1 term in geometric sequence, or S sub 1, since there is only 1 recipient of the text message, then it is equal to 1. For series of 2 terms in geometric sequence, or S sub 2, you will get the sum of the first and second terms, and you will get 4 total numbers of text recipients. For series of 3 terms in geometric sequence, or S sub 3, you will get the sum of the first, second, and third terms, and it is 13 numbers of text recipients. Those are the examples of getting the series of the particular number of terms. But we are asked to get the number of people will have received the text message by 10 a.m. So in the list, 10 a.m. falls into 4th term of our geometric sequence, so we will get the series of 4 terms in geometric sequence, or S sub 4, and you will get the sum of the first, second, third, and 4th terms, and it is 40 numbers of text recipients. How about by 1 p.m.? Since 1 p.m. falls into 7th term of the geometric sequence, so we will get the series of 7 terms in geometric sequence, or S sub 7, and you will get the sum of the first, second, third, fourth, fifth, sixth, and 7th terms, and it is 1093 numbers of text recipients. Types of geometric series. The first one is finite geometric series, and it is a partial sum of geometric series. To find the partial sum of the first n terms, the partial sum of n terms of a geometric sequence is given by this formula. S sub n is equal to a sub 1 times the quantity of r raised to n minus 1 over r minus 1 for any r is not equal to 1, where S sub n is equal to the partial sum of the first n terms. A sub 1 is equal to the first term, n is equal to the subscript or the number of terms, and R is equal to the common ratio. For example number 1, find the sum of the first 5 terms of the geometric sequence. We have 2, 8, 32, and 128. So, our common ratio is equal to 4. What makes that 4? Because a sub 2 divided by a sub 1, which is 8 over 2, it is equal to 4. A sub 3 over a sub 2 is equal to 32 over 8, or it is equal to 4. Or a sub 4 over a sub 3 is equal to 128 over 32 is equal to 4. As you can see, there is a common ratio of the two terms in a geometric sequence. As we continue the example number 1, a sub 1 or the first term of the given geometric sequence is equal to 2. R is equal to 4 as we computed the common ratio earlier. N is equal to 5 because we are looking for the sum of the first 5 terms of the geometric sequence, and S sub 5 is what we look for. So, we are going to use this formula. S sub n is equal to a sub 1 times the quantity of r raised to n minus 1 over r minus 1. So, S sub n should be substituted with S sub 5 equals 2, which is the value of our a sub 1 times the quantity of 4, which is the value of our r, raised to 5, which is the value of our n, minus 1 over 4, which is our common ratio, minus 1. And we are going to simplify them further, and it will become S sub 5 is equal to 2 times 1024 minus 1 over 3. And the sum of the 5 terms is equal to 682. For example number 2, a billionaire decided to celebrate Christmas as a Thanksgiving by donating 1 peso on December 1, 2 pesos on December 2, 4 pesos on December 3, and so on through December 25 to the Lingap Kapwa charity. As you observe, the donations form a geometric sequence. What is the total amount of donation? In order for us to answer this question, we need to find the common ratio because, again, these donations form a geometric sequence and it is equal to 2. How did we get the common ratio? Okay, to find out the common ratio, a sub 2 over a sub 1 is equal to 2 over 1, and it is equal to 2. And then we have a sub 3 divided by a sub 2 is equal to 4 over 2, then it is equal to 2. That is why their common ratio is equal to 2. Continue the example number 2. A sub 1 is equal to 1 because there is 1 peso as the starting amount of donation on December 1. R is equal to 2 as we computed this one earlier. N is equal to 25 because the last day of donation is on December 25. So, S sub 25 or the series of 25 terms is what we are looking for. So, the solution is S sub n is equal to a sub 1 times the quantity of r raised to n minus 1 over r minus 1. The next process is to substitute all the given values that we have. For S sub n, substitute it with S sub 25 equals 1, which is the value of a sub 1 times the quantity of r, which is 2, raised to n, which is 25, minus 1 over 2, which is the value of our r, minus 1. And we are going to simplify them further. So 1 times 33,554,432 minus 1 over 1, or the series of 25 terms is equal to 33,554,431. Therefore, the total amount of charity is 33,554,431 pesos. The type of geometric series is infinite geometric series. It is the indicated sum of an infinite geometric sequence. If the first term is a sub 1 and the common ratio r, then the infinite geometric series S is S sub n is equal to a sub 1 plus a sub 1 times r plus a sub 1 times r raised to 2 and so on. In finding the sum of an infinite geometric series, the sum S of an infinite geometric sequence is S is equal to a sub 1 over 1 minus r, where a sub 1 is the first term and r is the common ratio, and the absolute value of r is less than 1. Example number 1. Find the sum of each infinite series if it exists. Explain why the sum exists or does not exist. So the given geometric sequence is 1 plus 1 over 5 plus 1 over 25 plus so on. To find out the common ratio, we are going to use this process. A sub 2 divided by a sub 1 is equal to 1 over 5, which is the value of our a sub 2, over 1, which is the value of our a sub 1, equals 1 over 5. So you are going to divide a sub 3 divided by a sub 2 is equal to 1 over 25, which is the value of our a sub 3, over 1 over 5, which is the value also of our a sub 2, equals 1 over 5. Therefore, our common ratio is equal to 1 over 5. Since the absolute value of r is less than 1, or r is between negative 1 and 1, therefore, the sum can be determined. As we continue the example number 1, so these are the given. A sub 1 is equal to 1, our r is equal to 1 over 5, and we are looking for its series. So we are going to use this formula. S is equal to a sub 1 over 1 minus r. So S is equal to 1 over 1 minus 1 over 5, and S is equal to 5. Number 2. Find the sum of each infinite series if it exists. Explain why the sum exists or does not exist. So the given sequence is 4 plus 12 plus 36 plus and so on. So we have to find first the common ratio of this given geometric sequence. So a sub 2 over a sub 1 is equal to 12, which is the value of our a sub 2, over 4, which is the value of a sub 1. And the result is 3. So we have also a sub 3 over a sub 2 is equal to 36 as the value of our a sub 3 over 12 as the value of our a sub 2, and the result is 3. Therefore, their common ratio is equal to 3. Since the indication on identifying the sum of each infinite series is the absolute value of r is less than 1, and we computed r is equal to 3 and 3 is not less than 1, therefore the sum cannot be determined. Thank you for listening, math learners. See you next time.